and I'm doing anything but technical stuff. So communications, business development, a bit of community management, and also reaching out to people on LinkedIn, trying to get partnerships, things like that.
Yeah.
But I'm not involved in the code or anything.
Yeah, I'm Wouter. I'm the CEO and co-founder of Orpheus, and it started off as a mining company, and at some point we had acquired so much knowledge about Bittensor in general, and had someone with a lot of knowledge about the weather, who's sitting over here, that it only made sense to start our own prediction subnet.
Right, so I'm Eric. I am the lead machine learning engineer for Orpheus. And before joining Orpheus, I finished my master's in Cambridge. And as part of that, actually, at the final stages, did quite a large project on environmental forecasting, which is like the more scientific term for weather. So I will get more about that later, but I quite have researched this topic quite in depth. So that kind of made us choose this specific topic to build a subnet around.
It's a motley crew, and not a single one of you guys is actually a PhD in the weather.
No.
But that's what we're here to do, kind of break down and just disrupt every industry in the world without needing to be experts in it, because I'm sure that the miners on the network are like, you probably have like 30 PhDs mining Zeus. Before we continue, one question about the name. What is Orpheus?
Orpheus is the company that's just a mining company, or was a mining company, and is now the owner of Zeus. Let's just focus on Zeus. It's basically Zeus.
Okay, but is it related? Is like the name related? Like, where does that come from?
It was a random name. We had to come up with a name when we founded the company within like 20 minutes, and we asked ChatGPT, and he came with Orpheus, and we stick to the Greek god methodologies ever since. So therefore, Zeus and every other name you will see out there is all related to the Greek gods for no reason at all.
And we actually find out later on that there's quite some synergy, right, between the two. I think you...
Yeah, Orpheus is quite a cool story. It's about not looking back and looking forward, because looking back is wrong. And that's the Greek mythology story, right? And because they kind of like that trend, so we kept on using those names. And obviously Zeus is the god of, well, a lot of things, but also the god of weather. So that's why we kind of picked that name for this subnet.
And so Orpheus is the god of looking forward?
It's the complex mythological story. I won't bother you with the details, but it's about someone who should not look back.
And you guys were mining. I believe you were mining. Actually, you were mining the slot that you own. Is that correct? Were you guys mining 18? No.
No, we didn't mine the slots. We mined other subnets, a lot of them, but not 18.
And you formed a company to mine, the three of you guys?
No, I formed it together with my co-founder Travis, who is not here today, and our first employee was Ayed, and shortly after Eric, and we together mined a lot while Ayed and Travis were exploring potential businesses in Bittensor, other than owning a subnet. We were trying to validate for crypto companies. Nothing worked except for the
subnet.
The subnet.
And we currently have, we have 7 people now, right?
Yeah. This Monday we will be with 7 people, so we're growing. We're happy, and feels good. So let's focus on why weather makes sense on Bittensor. So why does a decentralized approach make sense in weather prediction? Currently, all the state-of-the-art models out there are all owned by centralized companies. And if you're a small company, you essentially make no chance against these really big companies, because you basically don't have the money to do so. But by using a decentralized approach, where you intelligently combine the forecast of miners that can focus on specific areas, you allow yourself to build an agent-alike system where the miners combined are better than the centralized teams. And on top of that, the centralized teams often optimize for historical data, which is not accurate in terms of like right now, where we are comparing the data from the miners continuously on the latest data. So it's actually better.
Right. So how does that work in practice? Well, we focus primarily now on grid structures. So there's our geospatial grids spread in latitude and longitude direction. And we don't just measure one time zone, we measure a couple of hours. So therefore those grids spread around in 3D. Validators generate kind of these bounding boxes and send them to miners and then ask miners to predict. Here you can see an example grid in blue on the spread around the Americas. And then on the left, it showcases how it's really spread over time. So that's why it has vertically stacked. This is sent to a miner, and miners then asked to predict a variable. We started with temperature, there's a bunch more now, at those exact locations, but in time points in the future. And then the validator waits a while, that has the actual ground truth data, and then it can compare how good was the miner doing in that specific location based on the mean error, the root mean squared error to be specific. Right. One thing you do run into when having this kind of difficulty measure, when like looking at that kind of scoring, is that obviously not every region is the same. You have a lot of these regions which tend to be in the ocean, and the ocean is very flat. And therefore, what's kind of going on is quite easy to predict comparatively, especially when you look at areas with mountains, such as the Himalayas over here. So here we actually plotted a variance in temperature, where more yellowish hue means it's a lot more variant, or more temperatures going up and down. And as you can imagine, it's a lot harder to predict those high variance areas. So what we've actually done, we've taken this information and created this difficulty factor Z, which we weigh in such that miners get especially rewarded for doing good predictions in areas with high variance, areas that are difficult. And it matters kind of less that they're really doing well in areas where it's really easy to predict, such as the middle of the ocean. In total, you kind of end up with this reward function. I really won't bother you all with all the mathematical details, but all you need to know is we focus on root mean squared error with your prediction or the miner prediction, and then kind of like the ground truth. And what we also focus on, what's really important for us, is a baseline, which in our case is open meta, which is actually like a really decent, well-performing baseline. But we want our miners to be even better than that. So we look at how well does this baseline do and how well do our miners do in comparison, both based on root mean squared error. And then kind of that improvement is your score as a miner. And those improvements are then scaled to be within 0 to 1, such as the best miner will get a score of 1 and the worst will get a score of 0. But so we primarily focus on having the lowest error, but then compared to an actual baseline that's already industry standard. And our miners are doing actually really well on this. And you can also see the difficulty scoring in here with the letter Z.
Yeah, so we've got a pretty good sense of how it works, but what our miners are actually doing. So we've been extensively discussing with them about all kinds of things. Sometimes you're just trying to solve their errors, and sometimes they're actually quite fruitful conversations. So what are they doing? Well, quite a few things. So for example, some of them are training new models. Some of them are fine-tuning existing models. And what most of them are doing is actually building smart systems to query models by location, time, and variable, or actually all three. And what the top miners do is all three of these. So what they do is they build a smart system to query models by location, and they train models where they feel like it's useful. They fine-tune existing models in certain regions, and this way they get a sophisticated system that does all three. And this is also how we ensure the best forecasts on the subnet. And what we do at Zeus is we scale one variable at a time. So we've built quite a modular subnet with clean code, which enables rapid scaling. And we tackle one variable at a time, and we move on to the next once the miners beat the baseline. And this method has proven to work. So miners are beating the state-of-the-art baseline on every variable. So we've got currently temperature, precipitation, wind, and dew point. And we really want to scale quickly. The next variable will be there within a week, probably. And then the next slide. So yeah, we're beating on every variable. Miners are beating the baseline, which is quite an intelligent API that queries the best open source national weather service models per location. So for example, the ECMWF in Europe and the NOAA in America. So this is quite a performance.
Yeah, so here is a visualization of the performance of the miners. In gray, you see the baseline we talk about a lot. And in this visualization, lower is better. And if you look at the mean performance of our miners, on average, the miners perform better than this baseline in general. And then we kind of put something on top, which is the best recent performer. This is a metric where we basically have a track record of every miner and their performance on specific variables at specific locations at specific times. And then we intelligently query those miners based on their track record. And this allows us to generate an even lower error rate, which you see on the right side. So we're basically utilizing the decentralized approach to get a better result. If we then take that to precipitation, we see similar results where the mean miner is actually better than the baseline. But then this BRP metric is even lower and allows us to get like super good results.
Yeah, I think it's good to add that this is analysis that we've done in the past. We've also analyzed the other variables, being dew point and wind. They're on our website in the Knowledge Hub. So how do we actually, as Zeus, capture all of these different specialized approaches? Well, what the Zeus API does is it intelligently selects the strongest performers. This is all about the best recent performer metric, which Wouter just referenced to. So the BRP identifies the miner with the lowest average root mean square error over a 24-hour rolling window for a given forecast period. This metric drives the validator's proxy's mixture of experts model, which always selects the miner with the strongest recent performance. By leveraging a decentralized network where miners specialize in different variables or regions, the API combines their expertise to provide more reliable forecasts than any single contributor.
Yeah, so a topic within the weather world is doing on-the-grid versus off-the-grid forecasts. I think you actually have to do this. Sorry.
I can also, up to you, but yeah, so what we're focusing on now is basically the left side of the image here, which is on-the-grid data, like error 5 that we're using right now. And that data is equidistantly spread geographically. So it's a grid, as you can see the green points. They're regularly spaced, they're consistent intervals, and it's very much globally consistent. You have no missing data, and it's everywhere. This data actually comes not from direct station measurements. It comes from complex physics simulation models that are run by European agencies afterwards to kind of generate this data globally, and that makes it globally complete. And it's very useful if you want to train a large-scale forecasting model like a lot of academic partners and academic institutions do. But on the other hand, there's actually off-the-grid data, and this data has a lot of properties that make it slightly harder to handle, such as being unstructured or irregularly spaced. It can happen at wherever locations, and it's obviously not equally spread around the globe. As you can see, the red dots, there's a bunch of them in America, and there's about none of them in Africa. But it does have a really, really nice property, which means that it focuses on a hyper-specific location. You actually have data for that specific location, as opposed to having these grids which actually have like 25-kilometer bounding like areas where there's no measurement. And these off-the-grid data points do allow for actual specific focus on points of interest, which makes them really powerful.
Yeah. So currently we're using the on-the-grid approach, which is good because we can we incentivize miners globally to predict on every single location. However, if we now want a prediction for a specific location, such as, let's say, a Formula 1 grid, we now interpolate the predictions around this point, which result in suboptimal predictions if you want really good predictions for this specific locations.
So how we're tackling this issue? Well, big announcement, we're actually expanding the validation layer. So we're going to diversify the validation, and that's we're introducing a second mechanism, or as we all probably know it, like a subnet, which is like a new feature. I think it launched a day or two ago. So what we will have is the existing competition based on the on-the-grid era 5 data, but we will host another one which will be based on these off-grid data.
Right, and this might seem like a really constructive problem, but I can assure you this is actually very, very relevant, because what tends to happen now in a lot of research labs and also actually in industry is that people have to choose between either of these modalities, because one of them is nice to work with globally complete, but doesn't really work nicely for downscaling and has all kinds of these associated issues of like, I want to predict this location. I don't want this computed data sets that's globally complete, but not at all at my location. And the other data set, while being very, very specific, it has the problem that it's obviously biased towards Western and like developed areas, because you can see the spread of the red dots. They're not at all equally spread around. And if there's none near you, then you basically don't have whatever measurement. So right now it's kind of, a lot of people have to pick and choose. So if you were to be able to use both of them at the same time, and you could actually train your models like that, which is really a new pioneering research area, that would actually be really, really promising. And that's actually something I have quite some experience with. So before joining Orpheus, I did my thesis in Cambridge on this project, and we actually ended up getting such good results that this, with my supervisors, we presented this at ICML, so the International Conference on Machine Learning, last summer in Vancouver. It was actually about this topic, so taking these specific modalities on and off the grid and kind of showcasing how both of them are really important, how you really want to conjoin both to get the best predictions. And this was specifically with transformer models, but you can do all kinds of models. But it's really taught me how much of a research area it is out there and how much it is overlooked currently in specifically combining these modalities to get really, really much better forecasts that are both hyper-specifically local and downscale really well, but that also have the ability to forecast at any location and that don't have these built-in biases by having data sets, which are basically the US and America and like Europe.
Yeah, and I want to emphasize, I think Eric's being a bit modest, like this ICML spotlight paper, this is a big deal. I believe it's the only one on this subject as well, and we really want to pioneer this with the subnet, pioneer this research direction. And it's a really hot topic in the weather forecasting space right now. And we're on the verge of doing so with the second subnet, which is, I think it's amazing.
Yeah, so the end result will look like this. We're basically going to combine what we're doing right now, which is in the green dots, and create a subnet or a new mechanism where miners are also incentivized to predict for these hyper-specific locations. And eventually, sorry?
If you go back a slide there, it seems like you guys are slightly biased, Amsterdam, or just like slightly 10 meters to the right of Amsterdam.
Well, we actually picked real world locations from weather stations, and they tend to indeed like
focus on capital cities, for example.
Yeah.
So you definitely see something like it.
And we're currently actually exploring a potential partnership with decentralized networks that allow you to buy really cheap weather stations. So basically, this allows people to set up their own weather station at their specific location. And then we will incentivize our miners to predict on this specific location.
Yeah, and we really, you were done, right? Yeah, really envision a future where anyone can, through us, buy a station like this, like all of you guys on Bittensor, buy a station like this, and we can actually provide the most hyper-local forecasts for that given location. And we envision a future where this will be used, let's say, around F1 grids, on top of stadiums, on top of skyscrapers. Like the sky is the limit once we are able to distribute all these systems and provide these hyperlocal forecasts.
So yeah, over time, Zeus will validate both reliable global forecasts, but also accurate local forecasts. And we will be the best API out there.
Damn right.
Damn right.
That's it, right?
Yep.
Yeah. We want to thank everyone listening today, by the way. Thank you for tuning in at this time.
Yep. Especially you guys, 6 a.m.
So, can we get a prediction of what the weather will be like tomorrow?
Sure.
From Zeus?
Okay, go to the Zeus subnet website.
Which location are you interested in specifically?
Seoul.
Right.
So
Let's take a look.
you want to like screen share that?
Yeah, we can probably.
Yeah, I'm doing it on my laptop, so that's.
You can do it on yours, I guess, and then we can screen share it.
So as
What
well.
am I doing?
I put you. This is the hot seat now. We're gonna do a live demo.
No, it's okay, man.
Let's do it on the
Yeah,
shared
if
screen.
you can do it on the
That's
screen,
better,
you
right?
guys will actually be able to see it, I guess.
Really love this website. Very beautiful website.
Let's do it.
And this is actually, as we speak, sending requests to miners and pinging it back.
So it's
wow.
pretty hot over there. It's gonna be 26 degrees. No clue what that will be in Fahrenheit.
Not bad.
Zoom in.
Not bad.
Correct.
Yeah,
Very
no,
well.
Also, just so you guys know, it's actually live in the sense that this has just sent through our validator a request to miners, which have actually predicted.
To the BRP miner.
Yeah, and the reason it's so fast is that recently, I think we forgot to mention this, but really recently, a tiny part of the incentive we made that you actually respond efficiently and in time, such that we can do cool stuff like this, so that we don't have to wait like the full 10-second timeout to get a prediction. We can actually do it in reasonable time. You can actually build a viable product, man.
Okay, so now go to just type it into Google. Weather and soul.
Let's see if we can like answer some questions from the chat. He's on Windows. Okay, I didn't expect that to be an issue.
If you, Witcher,
Give mobile app. We're actually working on that.
Yeah, I think Trevor's is quite far with it,
Yeah.
actually.
Witcher, I want to shit test what we're looking at here in terms of the temperature. So
I
go
think
go
Was
Go to
trying
Google.
talk, but we
We're trying
don't
to
hear
say,
it.
because we don't hear anything.
Yeah, we
Maybe
don't
that's
hear
our
anything.
issue. I'm not
Is
sure.
it maybe, Wouter, can you check if the screen share thing didn't break?
Can you guys not hear me?
Cannot hear you. Let's see. Did I mute it? Yeah, I muted it. I muted you. Sorry.
I'm so sorry.
Oh well, that's your fault.
Sorry.
Okay, great.
Wow.
We're back. Sorry. Sorry. Please repeat anything you said.
Yeah. I was gonna. Okay, now go to Google and see
Okay.
what Google has to say about. Just go to Google weather or whatever, and weather and solar.
Weather. Oh fuck. Of course. Oh, tomorrow, right?
Yeah.
Is it now showing? Are you...
Okay. So
Is
think
it
it's
showing both
quite-
screens? Both
No, we
things?
can't see it. We can't see it.
What's it doing on here?
oh sorry.
Just do another tab.
You can
There
see
you
it
go.
now?
Okay, and does this line up?
Yeah,
I would
that's
say
why
it pretty
now.
much does, yeah.
So here it peaks at like somewhat above 25, and here it says 28. So we'll see who wins. Usually we're like closer by 1 to 2 degrees, so that would like add up.
Wow.
If you can tell us tomorrow what the weather actually will be in degrees Celsius, I'm sure it will be closer to 26 on the peak than 28.
So we should definitely be going to Google and asking them to change their weather service because
Absolutely.
Now, what do they use to get that? They're just using what is it, the EH and
Well, so a lot of
NOA.
them are actually using, so the Open Meteor, which we're using as a baseline, asking our miners to beat, is actually the API that's used by a lot of like services. So like a lot of weather apps, maybe the one on iPhone as well, I think uses those kind of like APIs, and those APIs don't actually run any models themselves. Those APIs in turn just go to all the local weather stations, so the Dutch one, the European one, the American one, the French one, and they combine and aggregate their predictions into them. And we're kind of asking our miners to beat that. So by asking them to do this, way more challenge, like it was a hard challenge to beat. Miners didn't beat it from day one, but eventually they actually managed to beat it, and then we have something which is state of the art.
And the miners, they have to beat all of the weather algorithms implemented by people that are in that region of the world, right? So no doubt, there's probably a team in New York City, for instance, and when you guys look at these key, you said you're working with key points. Are we still winning when it comes to places like these key point places that you were mentioning? Do we know that information?
You mean like the off the grid, like the hyper specific locations?
Well, I mean, like I think like in Los Angeles, for instance, there'll be a dedicated team that probably focuses on weather specifically in Los Angeles, and they have a much smaller problem than Zeus miners. And when you guys look at the results from Zeus miners, are we just performing well when you're talking about northern Saskatchewan? But when it comes to these like points of interest, actually the specific models at these locations, are a little bit more bespoke.
Well, basically the grid is pretty wide, but if we benchmark against this wide grid, we currently outperform every single model or combining model out there. However, we also want to beat people on hyper-specific locations, so therefore we're introducing the subnets, and we're confident that we will also beat them on these specific locations. But go ahead.
It's pretty also important to stress that like a lot of the apps like Google Weather, they're not doing any of these computing themselves. They use the APIs, and those APIs in turn mostly rely on public domain weather services. which are accessible for everybody. So what our miners can do, especially initially, is kind of at first they're at least as good as what's current because they can use what's current because those are all public source, and then they can incrementally improve over regions. So our miners don't basically have to build from scratch. They can build from what's already there because that's already public domain anyway. There's very few private domain weather, although it's coming up a bit more, but it's very limited. So yeah,
right. Okay. So it's patently obvious that they would beat the weather models in LA because they're using them. They're already
they're using more intelligently, using them in combination with, for example, other data or other information that they might also have that model might not include yet.
That's interesting. Take us back to the slide, if you don't mind, where we look at the performance, because I think sometimes this can get lost in a presentation. So 10% better than these people. First of all, like what do we? Yeah, let's go back to.
I'm assuming
let's do temperature. It's the most intuitive one.
Yeah, that's okay. The unit that makes sense. They are in Kelvin, by the way. I'm assuming most US people based on Fahrenheit. Fahrenheit's about, I think Kelvin is about twice. It's like 1 Kelvin is about twice as big as a Fahrenheit, roughly.
Mm-hmm. And so this is a root mean squared error. It's a bit.
Interpret it as basically how many degrees off are we?
Yeah.
So if you look at the 0 to 1 day forecast, so basically if we ask a miner right now to forecast for in 24 hours, they on average on other APIs do above 1 degree difference, and our miners and especially the BRP is significantly below that. So I would say 0.75 or something like that.
Yeah, maybe it worked for people not in that area, but like why root mean squared error? It's basically literally just how much are you off. The only thing is that if you did that on average, you would kind of be canceling positive and negatives. That's why you square them first, add them up, then take the root again. So the unit of measurement is very much still just how much are you off, just in a way where you're not accidentally canceling out stuff.
And is that the right metric? Like when you're predicting the weather here, like perhaps the miners are overfitting to, when it's a normal day, they're always correct, but then a high variance event they don't really care about because you're only measuring root mean squared error, that your models might actually have higher variance and not actually be tuned to what people want or what people are expecting.
That's a very good point, but we only take the mean over that specific challenge that is sent to a miner. So we don't take their global mean. It's just every mean, and every box we send is only a very small global box and only a couple hours back to each other. So if they had this problem, then for that whole box, they would be off a lot. And then that whole box would have a really high root mean squared error, which we don't really see. So we can quite comfortably say that's not the case. Like we're not doing a global mean over, a month. We're using this metric on a very, very small box at a very specific couple hour time frame. So
but you're still averaging the miner's performance over time to get forward. No,
exactly. But if the actual prediction is not so hard to do, the baseline we measure against will also be lower. So we're averaging both the easy predictions for the baseline and for our miners. So it's just a relative metric. The actual 1 Kelvin difference doesn't really say too much. It's all about like the relative difference, and you just want to maximize this.
When you guys talk about, kind of, I'm perhaps I should get someone that's better at statistics up on stage. Like, but then, like for instance, you can potentially as an application for customers, what really matters is that you're never really wrong. Like so your max variance is I mean, I'm not saying this is necessarily the case, but like if I wake up tomorrow and it's snowing in Seoul, that's something that the local news station cares about never happening. But because that's an anomalous event, somebody that's optimizing for root mean squared error may never care about that anomaly. And so their models will overfit to the consistent weather of Seoul. Whereas a local algorithm may be actually optimizing for something else, which is like surprise or we're really reducing like a maximum variance in their predictions over time. Have you guys? Does that make sense?
Yeah, it definitely makes sense. Well, two things there is firstly, root mean squared error is like the metric used for like, so all the big models, both the ones done by like academic institutions as well as like the GraphCast and Aurora, which are done by like Google and stuff like that. They all are like, their metric is root mean squared error. So like it's basically what all of them are optimized for, at least the ones that I know of. And secondly as well, the one thing about it not actually being the mean is that it is a square first. So actual like large differences in a single point get get squared. So, and then you do take the average, but like that's not mathematically identical. Like you can interpret it as like how many degrees are you off? But if you were off at one specific location, like 10, that would square to 100. And if you average that, that would actually influence you substantially.
Yeah.
Right.
It would basically result you getting a 0 score versus the miner that did actually predict the event correct or close to correct, who got like a 1 score. And just a couple 0 scores after each other, you'll be kicked out of the competition. So you're actually incentivized to do it really well.
Cool.
And on top of that, in this slide I currently show, you also see that in the regions where the variance is higher, we actually incentivize miners to be better. That's what we're trying to do with this set score. It doesn't take into account the extreme cases you're talking about, but this is like taken care of by default by the RMSE metric.
I mean, it's very unique in Bittensor for teams to be able to get a network to work where there's potentially collaboration and a whole bunch of miners that are working on different aspects of the problem. Like there's a nice quality of your guys' problem where it is very compartmentalized, right? Your algorithm makes a grid, right? Which is like, it's not the case in like intelligence pre-training, right? You care about the overall score primarily. You can't really make a mixtures model of like 10,000 different large language models. It's just too slow. But you guys have this nice compartmentalization, and so it sounds like a lot of where you're going is getting way more sophisticated about that compartmentalization, not just from this grid being variance, but also purely well-defined points of interests that and like you're getting more and more detail here. Can we go look at your incentive curve, like and so what it looks like on tau stats, and just let's look at some incentive curve porn.
Yeah, but just getting on the previous one, you hit it on spot on the nail. That's exactly why this problem lends itself really well to Bittensor. That's actually why, like when I was describing the research I did previously, they were like, that sounds perfect for a subnet, because it's like really the kind of problem that compartmentalizes really well, but then also it's actually leading instead of the art. And you have the nice aspect where like you're predicting the future, so like good luck gaming that. Like it's literally, it hasn't happened yet, so like you don't have to worry about people doing like lookups, cheating. Like it's literally the future, so like good luck with any aspect.
Take us through an analysis of this curve. What do you guys see for the in the competition when you look at this?
Yeah, so like we are aware of the fact that the incentive curve is pretty flat. We were thinking previously about setting it to a winner takes all, but basically because of the huge amount of requests we want to be able to handle through our API, we decided that we're okay with miners spinning up like multiple services with the same model, because then we basically can handle more traffic. So therefore we're okay with the flat line curve, and the competition is like pretty close to each other. So all the miners are really close to each other. So we do not expect anything else. However, we're not like too happy with it. We will keep like building on making it better and incentivizing miners to be the best and getting like a more crazy score. But up until this point, we feel like this is the best method. And
this suggests, right, that there's certainly, I mean, you can see, right, the cold key distribution, the miners are not hiding. Like there's probably one guy who has at least 25% of the network here.
Absolutely.
And this suggests, and also like a lot of immune keys, it suggests that there's a bit of a game of cycling registrations in order to like kind of run many statistical samples, like, or run many trials. Like I'm just going to throw up a newly tweaked thing, and that can be positive sometimes in design. Is that what you guys see in practice? That like what miners are doing is basically coming up with a new method, registering a whole bunch of keys, and then tweaking those methods. Like how do you guys measure the variance in the performance of the miners? And like is there a potential for like the miners are actually using the network to train, like they're tweaking some hyperparameters and then just throwing things up onto the network and then just waiting to see what sticks?
Well, we are tracking the BRP metric a lot because we want to like optimize our API. And basically what we see is that we see a bunch of groups, and each one of them basically is the best in a single variable. We also really try to communicate with the miners that they don't like over-register specifically on their key, because we want to like keep the best miner for every single variable. And we've also previously like interrupted. Basically, we set the registration cost a little bit higher because we saw miners like massively registering miners and kicking out people that were beating state of the art on another variable.
Maybe also to add some more to that, we previously, because we're predicting the future, we have to wait until we can score a miner. So initially we had quite a large immunity period, but then actually about tonight I did a lot of analysis, like how short can we get the immunity period? Because ideally we don't want people predicted for 4 days, just because otherwise we can't score them. And we use like the alpha that scales like how much the next prediction matters for your mean score slightly, just so we can get a shorter immunity period to make sure that people don't kind of focus on that as opposed to actually focusing on the content of the subnet. So right now I think it's 1 day that we set it to.
Yeah, we set it to 1 day, and there's this adjustment alpha value, which basically, as Eric said, determines how much your new score updates your old score. And we set this pretty high for the first 24 hours, and then it goes down to like a really low value, so that eventually you will grow to your ultimate true score. And it also allows you to grow an incentive really fast without being deregistered or setting an insane immunity period.
And we did a notebook demonstration of how like the current values definitely allow you to be competitive within the immunity period while keeping the immunity period short, so you don't get people abusing it for all kinds of aspects.
Yeah.
Well, there's lots of alpha in there, and as you guys know, this is like deep Bittensor. But backing out of the nerd stuff here, improving the RMSE, and this being a metric that really matters to the industry. Your guys' baseline on the slides. If you go back to the slide deck, if you don't mind, there, Wouter. We had a graph in one of these pages that showed like a comparison. I just want to like break it apart, so like perhaps we can see understand what that really means.
This one?
This one, yeah, this one here, right? So you guys are comparing yourself against this open Mateo,
Yeah.
and is that really who you're trying to beat, or are like other teams in the industry? Like for instance, like a pay-to-play service that would go to F1, for instance, and be like, hey, like we'll get you the best predictions. You know, when you're making this comparison, is this the right baseline? What are those numbers? Like, how are they doing?
Should I take it up first?
Yeah, sure.
So right now, obviously, we are about to introduce the specific location, but it's not part of the subnet yet. So for right now, focusing on global grids, OpenMeter very much is the right baseline because it essentially aggregates all the local forecast and a couple of really big lab, large scale models, picking the best one of that free location, or at least they're like what they think the best one is. So for like a global, it's very much the right baseline. When we start introducing these like specific locations, then that might be up to you. But
wait, so in the grid from the perspective of the grid, what you guys are showing here is truly state of the art. Like this is, nobody can produce this chart except Zeus.
As far as we can tell, definitely not. Most of the state of the art performance metrics are all based on individual models, where this is about intelligently combining outputs, which is not a thing that is like measured a lot. But as far as we could tell, this was the best baseline we could find, and we're significantly outperforming it. and as far as we can tell, we're beating it.
And so that means that you guys you've gone to neural IPS, or you're going to neural IPS. Is that correct? And
It's the same.
Okay. Okay. And it's like the neural IPS for weather, and I'm sure there's a whole bunch of other teams out there that are training machine learning models that have publicly open source data. This is more accurate than their models.
Well, in general, what has happened is that they train a model, but already OpenMeteo uses. I mean, obviously, if they train it, this year, it might not be included, but if they train it really recently, but OpenMeteo already has a lot of these graph graphs, which originally came from research, and these kind of models in there, and because that's a baseline, we are beating those kind of by definition.
Okay.
Yes, I would, and especially by combining them, because especially in academia, it's not the focus is usually just, and that's something about to highlight initially. You have this frozen data set where you take a frozen year as your validation set, and you want to get the lowest root mean squared error on that. Whereas we're focusing on what's actually happening now, and that's not really the focus of most of these more academic focused models. So
right.
there's in general because we focus on it more and we reward for it, it tends to perform better on that.
And okay, but that's an open model. That's an open model. It's an open forecasting. They have all it's free to use. But in this space, there must be other for-profit, hardcore motherfuckers out there trying to beat the baseline and monetizing that edge, right? Because that goes to, I mean, we're going to get to that in a second, but it's valuable information. Can we show that as well? Is there a way for you guys to stand up and take a snipe shot at what who else is saying this in the world?
Yeah, so basically what would happen in that case is that one of these closed source models is used as an additional source for one of the models that are used to do the global predictions. And as we said before, this is the best baseline we could find out there. If there's something else that works better, we're happy to compare it, and we are quite confident that we will beat it as well, because the improvement is quite significant.
OpenMeteo is necessarily open, so it's not a proprietary service as far as I understand. You guys just query it and it gives you some results. So they're not paying. I guess what I'm saying is, if I want to go and pay for this graph, and there's another maybe a Norse god of weather company that they think they're way better than you guys. Maybe they're mining on Bittensor. So I don't know. What are those teams saying? And and what I'm saying is is this really the proper baseline when you're taking this to enterprise?
I think especially on global grids it is, because there isn't actually any of I know of for the best models doing global forecasts are models coming from academia or Google research, which is quote unquote academia, but these kind of labs that make these models are, and those are included in OpenMeteo, are the state of the art for global forecasting. There might very well be proprietary companies which, I don't know, have the best forecast at this specific F1 track because they have measurement devices there, which we don't have. So that's why we don't yet have. So that's why we're expanding into that domain. But in the global domain, which is where this graph comes from, the best models are the ones that are open source.
Yeah. Or sometimes the models itself are not open source, but the actual forecast is open sourced. So, for example, in Europe, you have a weather station, and they actually open source their forecast. Our miners are definitely utilizing those forecasts and combining it somehow with other predictions or other models. But those guys are beating the state of the art in terms of models, and the actual outputs are open sourced. So yes, to answer your question, yes, this is the right baseline. Absolutely.
And when for these proprietary teams, you said that they have different metrics, but they also have different sensors. I mean, surely there's no company in the world that actually has sensors globally, or are there actual private weather sensors set up by these teams, these private labs in every country of the world and every grid? No.
So those are indeed more local, and that's exactly what we meant. Where the best global ones are open source ones, because there is no proprietary one that has them everywhere. But if you look at specific locations, then you do have parties. And those specific locations, especially locations that are tied to some industry, so like all the F1 tracks, all the football stadiums, like that kind of, then you get obviously private parties which have like measurement devices there, but there's obviously none that have the capacity that like the European and American like government institutions for like environmental measurement do.
You guys talked about potentially getting the miners to set up that data or buy that data or get access to that data. How are you thinking about that problem?
This is about the subnet, right?
Yeah.
The additional mechanism.
No, actually, well, maybe. I would just specifically about how, like, in order to win when it comes to a very specific location, it seems like the in order to be the most sophisticated in New York, for instance, you'd need like custom on the ground weather devices, and
we're actively talking to a group that is setting up a decentralized data collection network where you can actually buy a really cheap weather station and install it yourself. And by combining like our resources, their data, and our forecasts, we can actually incentivize miners to do prediction on specific locations set up by these small, cheap devices. And it allows you to literally buy your own weather station, put them in your backyard, and we will incentivize miners to predict weather over there.
That'd be interesting, and like maybe the first time that Bittensor moves into the real world. I suspect you probably want to build like mining pools right out the gate. And it's a very interesting problem how you would verify that, but like we'd love to see it.
Yeah, there are actually projects out there that are actively like already distributing these devices with like thousands of units. It's not like a new thing we're trying to set up. We're just trying to combine the resources we have. And on top of that, it allows you to join that other network, collect data, and incentivize miners on Zeus to predict over there. If that makes sense.
Yeah, it does. Very cool. So let's go to the when revenue question, but lightly. I'm actually more interested before we talk about that. Not when revenue. I'm just kidding. Tell us about the actual market for weather. Like, what does it look like today? Who's, I understand there's people that are trading commodities potentially, and they really care. Who's going to buy weather data? Is it local news stations?
There's actually so many industries that utilize weather data. It's kind of hard to pinpoint the most important one. We decided that we want to focus on commodity traders, energy traders, banks, which will obviously be the ones willing to pay the most. But there are actually so much niche use cases for weather data. Like people advertise on weather data. Aviation uses a lot of weather data. Sports uses a lot of weather data, and there are like so much more. So yeah, there's lots of directions we can go into.
Yeah, and the most interesting one for me personally is the energy trading, because due to the increasing amount of green energy with like solar panels and wind turbines, it is also an increasing market to predict the weather and therefore predict this energy, because energy prices go up and down more and more, fluctuate more as the amount of green energy grows. So it's a growing market, and it's always interesting to jump on a growing market rather than an already established market.
So basically, if I mean, that makes sense, right? If it's really hot in Austin, Texas, everybody turns on their AC, right? So if it's that extra degree, and you're in the business of trading, I guess, energy credits or yeah, Austin mentioned for you, Rob. I mentioned and also because it's hot as hell, and I've been there, and it's terrible, and the AC is a super requirement. Yeah, that's cool. So that's an obvious one, right? So like we have a really hot day in Dallas, and we need to trade energy credits there. People need this data, and like that's a sophisticated market, and no doubt millions, if not billions, of dollars move.
Absolutely.
There's commodity prices, and I suppose also if you're predicting the weather far enough into the future, there's also like things like grains. Like, you tell us a little bit more about. Sorry, I shouldn't answer your question for you, but like, give us some more examples of where.
Yeah, so for example, what could also happen is that a bakery, for example, wants to run their operation once a day and needs a lot of electricity. And if they can like spin up their entire operation once a day on a specific time period where the energy prices are really low, based on our predictions, it can save them literally like millions of dollars. And I think the examples are endless. High performing athletes really depend on what the weather will be like, especially in things like tennis and cricket and soccer. Some people really have like bad sight when it's raining. Some people just can't stand the heat. Yeah, the list goes on and on. And for us, it's just probably important to focus on one of the markets, and we decided to go with the energy market, just because people were reaching out to us from the energy market area, nothing else.
I also read a paper quite recently, and there was an interesting metric. It says that utility managers only in the US, they save $500 million every year just by improving their weather forecasting model, in knowing when to run certain operations and do this energy efficient, which is a staggering amount, right? For just in the US.
Interesting. When it comes to these specific points of interest, is the future plan here that somebody can come to the network and actually put that point of interest on the map, so to speak, and Zeus will drive the miners to performing well on in that domain? Like, we care about this F1 track because that's where and so like in Monaco, you can go and sell to the Monaco F1 because you're like, hey, like it's a $100,000 a year subscription, but we will get you the best accuracy.
Yeah, so first of all, people can in the future buy their own device, and we will start predicting the weather over there. We are now using a difficulty grid that incentivizes miner to predict better in more difficult areas, but we can also like turn this around and make it more of a grid based on market needs and incentivize miners to predict better over there. So yeah, definitely we can do that by adjusting this map.
We could even do this on another subnet in the future. Who knows? The business subnet.
Mechanics, they were called, right? Or
Yeah, mechanism.
Mechanisms?
I think they changed the name.
It's a good point for just me to yeah, we're calling them mechanisms. Like, so subnets have mechanisms instead of subnets. Just it makes sense, and it's actually very correct. So it's important to mention here, just for the crowd, also that when you have subnets, you can't have UID pressure. So you guys have UID pressure because of the you can see the immune keys, and then you can see the cycling that's occurring, lots of registrations. So subnets won't work for you guys because one mechanism will push out all the miners from another mechanism. Something to keep in mind. So so you probably will want
to takes all then after all.
Yeah, or like top N. We're gonna be exploring how this works in an elegant way over the next couple of weeks. By the way, I think they're doing the upgrade right now, literally as I speak, which is exciting.
Cool.
And okay, so really beautiful presentation, and so right now Zeus is an open platform. People can come to Zeus, they can use this, they can pay for it. Is that correct?
Yeah. We do have an onboarding because we don't want people to use it out of the blue to prevent relay mining, basically. But you can use our dashboard to predict the weather in Seoul, for example. And if you're a serious client, then contact us and we will definitely
onboard you.
For sure.
Yeah.
It looks like the upgrade was a success. So everyone can go away from the call and make their subnets and to register subnets as well as we speak. That's happening.
The deregistration is also part of the upgrade.
Yes.
Awesome.
It's a fairly large upgrade. We're at 320. Okay, but that's not for here. And what are the number one things you guys want to focus on over the next quarter?
In increasing the amount of variables, and reducing UID pressure probably.
Yeah, and introducing the local, like.
Oh yeah, of
That's
course,
the biggest,
of
I
course,
would say,
introducing the upgrade on the subnets and figuring out how to do that.
Yeah, so focusing on not just spatial grids, but focusing on specific locations and making miners perform well at that location, those locations.
And
Tell
also
us about-
the API, of course.
Tell us about the journey that you guys have gone through from miner to subnet owner. Like, do you wish you could go back?
Yes and no. When you're a miner, you're sometimes frustrated because updates happen, because people want to like continue. So that's frustrating as a miner. We often had like people randomly updating things because they just want to move fast, and Bittensor is moving fast. It was really frustrating. And now we're doing the same thing for miners, and we get like a lot of feedback about, oh, this is not fair, blah blah blah. So we're on the other side. Yeah, we actually used the miner 34 and
So that explains Dylan's remark. Yeah.
yeah.
It's something we do try and keep in mind, where like especially if we do an update which will actually require manual intervention, we'll try and give them as much like both headspace, like time in advance, as well as like provide like a default miner, which obviously isn't competitive, but at least like so they have something in place for, I don't know if they weren't able to update quickly enough, because that's something we really like learned from having mined previously. Like you don't want to dump an update on miners, requiring them to retrain all their models overnight. So like we really try and avoid that wherever we can. I think that's something we learned from.
And we now all of a sudden have to think about alpha numbings and things like that. We are a machine learning team, so it's sometimes hard to do those things. But yeah, people from the community are helping us out, so that's also a good thing.
Well, guys, this was a fascinating conversation. We're right on the hour. And unless we want to dive more, I mean, in some sense, this problem is perfectly designed for Bittensor, right? You have real ground truth data. You have a distributed problem, and I when people ask about Bittensor, they're always surprised that we do really well on these kind of problems, because like, you're a decentralized AI protocol. But the fact that we're winning in this field as well, like you guys showed on your stats, that we really are the best in the world. I really hope that gets out there to your customers, and that we can actually get use cases in dog food. Zeus, this is an awesome presentation. Thanks, guys, for coming onto the call and going deep into it. Perfect.
Thank you so much.
Thank you
for having us on and creating Bittensor, because that allows us to build this amazing thing.
Let's continue to
Thanks
build it.
everyone in the audience as well.
Thanks,
Do you
audience.
want to like answer some questions, or are we?
If there's
yeah.
any new questions,
Let's do that. Yeah. Okay.
Let's do 3.
Okay. Let's do 3. Okay. I'll try to ask them. So people put them into the chat if they still have them. So while we still have a bit more time.
I see a lot of fire.
Yeah, I was going to say one that isn't just an exciting emote. I think Dylan's trying to do Dutch, but
There's
Okay,
there
Karsten. From Manifold. Probably something about Austin.
maybe any questions we've missed that were during the presentation. We couldn't actually see the chat, so maybe some old questions. Nederland.
How are miners over distributed between the two mechanisms? This is something we still have to figure out.
but I think we should mention like the one what's currently like the on the grid. Obviously, that will stay very important. I would say initially that will stay the majority, right? Like
Absolutely.
when we pioneer something, we're also
Yeah.
like we try and test it, but obviously like it's new, so we're not gonna make that like all the alpha. Like obviously what we know works will stay the majority, and then we can. I mean, we do the same when we introduce a new variable. We introduce it at slightly lower frequency just to see if it all works well, and then we scale it up slightly once people actually know what we're doing with it.
And this is a comment that I think there's a concerned person with the mechanism saying something about you guys reward the speed at which responses are made.
Yeah, so something like that. We did that recently, but it's first of all, we should stress it's a small fraction of the reward, and we'll probably shrink how much it weighs even more, just because it shouldn't be the majority, and it isn't. Like the majority is still, are you the best miner? Are you performing the best predictions? It's just that we notice that like sometimes it would take very long, or we notice like we want an API that's both really fast and it's both fast globally. We notice a lot of miners were quite fast at the same data center as a validator was. And that's not really useful for a product. It has a single point of failure, and it means that you're a very slow product everywhere that isn't Frankfurt, Germany. So ideally, we didn't want that anymore, and therefore we've incentivized it now. But it isn't like it's a part, like a small part of the incentive by anonymous.
Yeah. Also, one comment. I think this was actually someone talking about the BRP, and then a comment on that about that the best miner, which would be like the best recent performer, is not only about RMC but also about response time. But the BRP actually only measures the RMC.
Yeah.
So the BRP, the best recent performer, which is how the subnet captures all of the value, is not about the response time at all.
Oh.
But
So
there is
the
an
reward
aspect of response time. Is that correct? There's a small aspect. There's a small aspect of response time.
It's a small aspect of the reward, and it's not an aspect at all in the BRP.
I would suggest making it just a thresholded value, so like you have to respond within 5 seconds, rather than making it a continuous value, because with a flat incentive curve like you guys have, people will just compete on that to make small improvements because it's so flat, right? That they can reduce the performance of their algorithms while.
But the issue with thresholding is with the inherent nature of networking. It's like either you have to set the threshold quite high, because otherwise you're half the time penalizing people for just something that might be out of their control for that specific challenge. But if you set it quite high, you get slow responses, and we can't build the product like we just showed. And if you set it too strict, you're going to get in scenarios where like it's pretty much all or nothing. And right now, at least, and also what's important to know, it is capped. So we base it on the medium response time, and then like if you're fast enough, so like you're the top 20-30% of speed, you get the perfect score for speed.
Yeah.
So we already have that kind of, but we do scale it down just so that like if the validated internet's acting up, if that specific challenge might just be a bigger data size, or I don't know, your network cable's acting, like those kind of things, you're not suddenly punished completely. It's just slightly. So that's what I mean.
Right. It does.
I think as if the threshold is already there. Although if you initially look at it, it might not feel like it. But if you're just like a little bit above average, you already get a score of 1. So it isn't that big of a deal, and it's also a small part of the incentive. So
I think that this is a good reason to use no UID pressure and potentially look at. I mean, one of the things that you guys said, just getting into the inside baseball of incentive mechanisms, like you said that you want to have more miners. So that you can actually have a product running on top of the miners, and what you're not always getting what you think you're getting there, because what happens is obviously one miner has 25% of the keys, so you think that you're incentivizing 256 endpoints that can potentially load balance the responses or the requests, but in fact you actually still have 7 endpoints, and also is that really the way in which you guys want to scale? And in fact, it would be much better if you had a dedicated side of the network with low UID pressure, which was just purely for inference speed, that was supposed to have exactly the same score as like this miner over here, or something like that. And I think that it's all these things, like the fact that you guys are already state of the art with these like micro things, but I think that you could improve in terms of the mechanism is incredible, right? Like you guys could go all the way to like Bittensor subnets are exponential, right? It's like you're being state of the art, but next tweak and now it's like you're so far ahead of the state of the art that there's no.
Absolutely. I agree. I think the only reason that it is as it is, we're just iteratively trying to improve. We're always open to suggestions. Every single time a miner suggests something, we of course take it with like a grain of salt, because they always want to be at the top. But if it's actually like sensible, we try to implement it, put it on the board. It will take a while because we have to like do some analysis, but we're open for discussions. And if anyone from the chat or you has like potential improvement, we will definitely look into it. And we're, as I said, like open to improvement, because that is what we're doing like all the time.
Yeah, I mean, this feature was also implemented like 4 days ago.
Yeah,
3 days ago,
nothing set in stone. We changed the ratios depending on how subnets. Ratios, I mean, like what challenge is most important, how much everything weighs. Like we continuously try and tweak it so it's perfect for the state right now. Because obviously you can't know those things in advance. You can do your best at estimating.
Yeah, I think this is a moment I'm noticing in the chat. I'm like that there's some concerned miners here. You know, it's always like this, and this is why it's great to listen to your miner community, because they like understand what it's like in the mines, right?
Yeah.
It's hard
That's
down in
true.
the mines.
Yeah.
Guys, this was fascinating and very fun. And thanks for coming on. And good luck.
Thank you so much.
Have a good day, everyone.
Thanks, guys.
Thank you so much.
Okay. Bye bye.